Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I had started the new chapter in 9th standard mathematics, that is chapter 8, which was on quadrilaterals. So in that particular video, I had explained different theorems of parallelogram starting from theorem 8.1 till theorem 8.7. So now based on those theorems, we have few examples. So now we will look into the first example in this chapter, that is example 1. Before proceeding with this particular video, please watch my previous video to understand different theorems of parallelogram. Now coming into the example 1 in this particular video, we have to show that each angle of a rectangle is a right angle. So here we have to consider a particular rectangle. So now let us consider a rectangle like this. So in this particular rectangle, you need to prove that all the angles are equal to 90 degree. This is what you have to prove. Now we will consider a particular rectangle ABCD. So rectangle is also an example for parallelogram. Remember that. So here AD will be parallel to BC, DC will be parallel to AB. So in order to prove this particular example 1, we have a simple technique. But here we have to use the concept of parallelogram and then we have to prove that all the angles are equal to 90 degree. So what is the simple concept is that we all know that sum of interior angles of a quadrilateral is equal to 360 degree. So here angle A plus angle B plus angle C plus angle D is equal to 360 degree. And we know that in a rectangle, all the angles will be equal to each other. So that is angle B is equal to angle C is equal to angle D. So all these angles are equal to each other. So in the place of writing B, C and D, I can just write angle A. So that means angle A, in the place of B I can write angle A, in the place of C also I can write angle A, and in the place of D also I can write angle A, which is equal to 360 degree. So 4 times angle A is equal to 360 degree. So that means here angle A is equal to 360 degree divided by 4, which will be equal to 90 degree, which will be equal to B, which will be equal to C, which will be also equal to D. So this is the simple proof which we can prove here. But here in this example, you have to use the properties of parallelogram and then prove this particular example. If you have to do that, then you have to construct a triangle in which one angle is equal to 90 degree. That is, this particular angle is equal to 90 degree. So ABCD, if we consider ABCD as a triangle where A is equal to 90 degree. So here consider triangle ABCD such that angle A is equal to 90 degree. Now here, since rectangle is a parallelogram, since rectangle is a parallelogram, so since rectangle is a parallelogram, here angle A will be equal to angle C and angle B will be equal to angle D. So now we know that angle A is 90 degree. So 90 degree will be equal to 90 degree, that is equal to C. So now we have got angle A and angle C as 90 degree. Now we need to prove angle B and D are 90 degree. So here basically what we are doing is that we are considering a rectangle in which already one angle is equal to 90 degree. And we also know that rectangle is a parallelogram. So since rectangle is a parallelogram, here opposite angles are equal to each other. That is A is equal to C and B is equal to D. And since we know A is equal to 90 degree, since A is equal to 90 degree, therefore C is also equal to 90 degree because angle A is equal to angle C, because opposite angles in a parallelogram are equal to each other. So in bracket you can write opposite angles in parallelogram are equal, or straight away you can use theorem 8.5. So according to theorem 8.5, opposite angles in a parallelogram will be equal to each other. Similarly, angle B is equal to angle C. So now this particular rectangle is a parallelogram. That means DC will be parallel to AB. So if you are considering this particular line AD, this acts as the traversing line for this DC and AB parallel line. So sum of the angles on the same side of traversing line will be equal to 180 degrees. So that means if you add this particular angle and this particular angle, that will be equal to 180 degree. And here DC is parallel to AB. So DC is parallel to AB and DA is a traversing line. So DA is a traversing line. Therefore, angle A plus angle D is equal to 180 degree. In bracket you can write, so sum of angles on the same side of traversing line. So you can write that statement. So angle A plus angle D will be equal to 180 degree. So here we know that angle A is 90 degree. So angle D will be equal to so 90 degree plus angle D will be equal to 180 degree. So D will be equal to 180 degree minus 90 degree, which is equal to 90 degree. We know that B is equal to D, which is equal to 90 degree. So that means here we got A is equal to C, which is equal to 90 degree, which is also equal to B, which is equal to D. So that means all the angles in a rectangle is getting equal to 90 degree. So that we had to prove in this example, and we have proved that. Now we will look into the next example, that is example 2. So in example 2, you have a particular diagram. So let me draw that particular diagram. So here, diagonals of a rhombus are perpendicular to each other. So now in this example, ABCD is a rhombus. So here in this ABCD rhombus, these diagonals are perpendicular to each other. So that is what you have to prove. So always you should remember that in a rhombus, all the sides are equal to each other. So rhombus is a quadrilateral in which all the sides are equal. So that means AD is equal to DC is equal to CB is equal to AB. We need to prove this particular angle, this particular angle, this particular angle, and this particular angle is equal to 90 degrees. So all these angles should be equal to 90 degrees. That means here DB is perpendicular to AC. So BD diagonal is perpendicular to AC diagonal. That is what we need to prove here. So in order to prove that, here consider ABCD as a rhombus, or you can consider a rhombus ABCD. So here, since this is a rhombus, AD will be equal to DC will be equal to CB will be equal to AB. So AD is equal to DC is equal to CB is equal to AB. So now in order to prove that this particular BD is perpendicular to CB, we need to prove one of this angle is equal to 90 degree, that is AOD. So let's call this particular point. So let us call this particular center point as O, and we need to prove that this particular angle is equal to 90 degree. Now in order to prove that, we will consider this AOD triangle and DOC triangle. So we'll consider this particular triangles. So these triangles we can consider. So we'll consider these two triangles, that is DOC and DOA. So these two triangles we'll consider. So here consider triangle AOD and triangle DOC. Here, since ABCD is a rhombus, so since ABCD is a rhombus, therefore ABCD is a parallelogram. Because if you remember 8th standard mathematics, all rhombus are parallelogram. So If ABCD is a rhombus, then ABCD will also be a parallelogram. So in parallelogram, diagonals bisect each other. So that means this particular side will be equal to this particular side. So here AD is equal to, so we are considering these two triangles, that is triangle AOD and triangle DOC. Here AD is equal to DC. This is already given because this is a ABCD is a rhombus. So ABCD is a rhombus. Since ABCD is a rhombus, here AD is equal to DC and AO is equal to OC because ABCD is also a parallelogram. ABCD is also a parallelogram and DO acts as common side. So that means here we are getting AD is equal to DC and we know that AO is equal to OC because ABCD is a parallelogram, and here DO is equal to DO because this is because common side. So because DO is a common side, we can consider DO is equal to DO. So according to SSS theorem, so therefore according to SSS theorem, here these two triangles, that is triangle AOD is congruent with triangle DOC. Since these two triangles are congruent with each other, this particular angle and this particular angle will be equal to each other. So here, therefore, angle DOA is equal to angle DOC. This is because triangle AOD is congruent with triangle DOC. So now these two angles are equal, and we also know that DOA is plus DOC is equal to 180 degree. This is because linear pairs, because these two acts as linear pairs. So since these two are linear pairs, sum of these two angles will be equal to 180 degree, and we know that these two angles are equal to each other. So in the place of writing DOA, I can write DOC only because DOA is equal to DOC. So in the place of DOA, I am writing DOC plus DOC is equal to 180 degree. So therefore 2 DOC is equal to 180 degree. So therefore DOC is equal to 180 degree by 2, which is equal to 90 degree. So DOC is also equal to DOA. So DOC is equal to DOA is equal to 90 degree. So therefore BD is perpendicularly bisecting AC. Diagonals in a rhombus are perpendicular to each other. Now we will look into the next example in this particular chapter, that is example 3. So in example 3, if ABC is an isosceles triangle, so here they have given one particular diagram. So let us draw that particular diagram over here. So here we have ABCD and this particular BA is extended up to point P. So here one diagonal is written, that is AC. So here ABC is an isosceles triangle. So that is AB is equal to AC. So here one more data they have given. This particular angle PAD is equal to DAC, this particular angle. So here AD is bisecting this particular A angle. CD is parallel to AB. So that is AB and CD are parallel to each other. So based on these data, first question in this example 3 is you need to show that DAC is equal to BCA. You need to show DAC is equal to BCA. So these two angles you need to prove they are equal to each other. So one concept we'll just see in this particular question. So if you have a triangle like this, and if one side of a triangle is extended, then this acts as the exterior angle for this particular triangle, and this exterior angle will be equal to sum of these two interior angles. So if you add those two interior angles, then that will be equal to this opposite exterior angle. So this is exterior angle property of a triangle. So Based on this rule, we will apply this particular rule here. So this total angle, acts as the exterior angle. So here consider triangle ABC. So if you consider triangle ABC, this angle acts as the exterior angle, which will be equal to these two angles, that is angle ABC and angle ACB. So consider triangle ABC. Here CAP is an exterior angle. So CAP is a exterior angle. Since CAP is a exterior angle, here CAP is equal to ABC plus ACB. This is because of exterior angle property of a triangle. So exterior angle of a triangle. So this is one property of exterior angle of a triangle. So CAP, this total angle CAP is equal to sum of ABC and ACB. Since ABC is an isosceles triangle, opposite angles of these equal sides will also be equal to each other. That is, angle ABC will be equal to angle ACB. So therefore, we know that, or else here we know that CAP is equal to ABC plus ACB, and we know that ACB is equal to ABC. So in the place of ACB, I can write ABC only. CAP is equal to ABC plus ABC. Therefore, CAP is equal to 2ABC. So we'll call this as equation 1. So here one more data they have given, that is PAD is equal to DAC. So they have given PAD is equal to DAC, and the total angle CAP is equal to PAD plus DAC. This is already given. PAD is equal to DAC is already given, and we know CAP is equal to PAD. The total angle is equal to the PAD plus DAC. So we know that PAD is equal to DAC. In the place of PAD, I can write DAC only. So CAP is equal to DAC plus DAC, which is equal to 2DAC. So that means here CAP is equal to 2DAC. Let's call this as equation 2. And from equation 1, we have CAP is equal to 2ABC also. So this is also this equation 1 we have. So here you can see LHS are equal, so RHS should be equal to each other. So therefore 2DAC is equal to 2ABC. So therefore DAC is equal to ABC. So here ABC is equal to BCA because ABC is an isosceles triangle. So we know that ABC is equal to BCA. So therefore in the place of writing ABC, I can write BCA. So therefore DAC is equal to BCA. This is because angle ABC is equal to angle BCA. So here they had asked to prove DAC is equal to BCA, and we had proved that. So now in second question, you need to prove that ABCD is a parallelogram. So we need to prove ABCD is a parallelogram. So here, since DAC is equal to BCA, therefore this particular AB will be parallel to CD. So here we had just now proved that this particular DAC is equal to this particular BCA. Therefore AD will be parallel to BC. This is because DAC is equal to BCA, which acts as alternating angles. So here if you look at this particular diagram, and if you consider AC as the traversing line, then this particular line AD will be parallel to BC. And they have already given AB is parallel to CD. So, and already they have given AB is parallel to CD. So here AD is parallel to BC. So therefore AD is parallel to BC, that we have proved now, because here DAC is equal to BCA, and they have already given this particular AB is parallel to DC. This is already given. So since opposite sides are parallel to each other, therefore ABCD is a parallelogram. So hence we had proved that ABCD is a parallelogram. So this is all there in this particular video. The remaining examples and the exercise 8.1 I'll be discussing in my next video. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.